So like I said, this is our webinar on intelligent and lightweight design in Creo 8.0. So the objective here is going to be using a combination of generative topology optimization, or GTO, and lattice functionalities to create lightweight yet strong designs. So I'm going to go over a little bit of an introduction of myself and boundary systems. Then we're going to go through these tools, and I'm going to demonstrate how these tools kind of play together to be used in our design process. So about myself, my name is Anthony, or AJ Vetterini. I have a Bachelor's of Science and Engineering in Aerospace and Mechanical Engineering, and I have about 4 going on 5-ish years with CAD and FEA tools. And I've kind of lived in this simulation world for the past 3 or 4 years. About boundary systems, so we see ourselves as a technology leader and are part of the PDSVISION global group. So on the map on the right there, you could see locations that we now operate out of. So we're headquartered in Cleveland, Ohio, but we have offices, as you could kind of see, all over the place. And again, that's kind of being a part of the PDSVISION group. Capabilities-wise, what we really specialize in, product lifecycle management, data management, cloud services. We also do a lot of CAD design consulting, simulation consulting, and product development. So that's stuff we do. In terms of where we're accredited and what we are noted in, we are a PTC Platinum partner, which gives us advanced capabilities when it comes to helping out regarding PTC products. We're also a Windchill certified implementer and an authorized and certified training partner within PTC. So we kind of live within the PTC sphere and help out with their products. But on top of them, we also support a wide variety of other products, which you can see on the screen now. A couple I will shout out are like Cymerics, which is CFD results, Keyshot, which is like real life Photoshop rendering, Moldex 3D is mold flow simulation, and we have some other softwares here that we do specialize and work with. So past that introduction, we're going to get into the actual webinar itself. So the 2 tools we're going to talk about today are generative topology optimization and the lattice feature and its added functionality inside of Creo 8. So generative topology optimization is a product made by Frustum, and it utilizes topology optimizations and FEA structural simulations to create designs that humans might not traditionally think of. So it will consider things like your manufacturing constraints. So for example, if you only have access to milling, you can set forth a linear extrude manufacturing constraint. If you do have like things like 3D printing capabilities, which is what we're really focusing on here today, you can, specify things like a minimum crease radius or a extrusion direction. So we'll consider things like that and generate, unique designs. The other tool we have is the lattice feature. So this tool has been inside of, Creo Parametric for a while. However, what's new in Creo 8 and is what we're really going to focus with is the ability to adjust our lattice density and variability according to a density field. So we're going to be able to take in our stress results from a simulation and use those to kind of play with the variability of our lattices, which we can kind of see in figure 2 in the bottom right there. So the overall goal of it will be to lower our part mass while accepting, larger stress values. It will consider, the part material, and we won't go above the part materials, tensile yield or anything like that. But we will, accept larger stress. Now to get a little bit of a deeper talk into these specific tools. Generative topology optimization, like I said, it's going to use our manufacturing constraints and the structural FEA analysis to generate a design that you might not have intuitively thought of. It will use multi-buy design, so it's only available at the part level in its current build. And the types of things we can do inside of GTO, we can specify a starting body, so starting region, which is the clear body you see in figure 1. You can specify what is preserved, so geometry that must be kept the same. Those are things in blue. We can exclude certain regions, so geometry will not be created there. And from all of that input, as well as an FEA simulation and your manufacturing constraints, generative topology optimization will generate a design that will satisfy or limit the part mass. Sorry. The next tool we have is Lattice Variability. So the new functionality, which I'll get to in a minute, is the ability to use Creo Simulate or Creo Simulate Live and export numerical results. So what that will do is it will take a random sample of however many points and report out the stress values at each of those points. And using that point data set, the lattice feature will be able to change the density of lattice elements to satisfy that essentially sample of 1,000 points. So we could still define out characteristics of our lattice. So depending on what kind of geometry of our lattice we want, we can still change and play with those. However, now we can actually use simulation results to change the density of our lattices. So what functionality is specifically new to Creo 8? In terms of GTO, there was a generative design extension, which was introduced in 7.0.2.0. That lets you run many GTO optimizations on a PDSVISION cloud. We also have the ability to use an automatic starting geometry envelope, which we can see in figure 1 here, where we just have specific areas we know must be kept for geometry. So for example here, maybe this is some kind of bracket, and we know where it's bolted in and where it's fixed, let's say, or where the load and where it's bolted down here. And we want the geometry just to generate and see what it comes up with, which is this, kind of crazy looking shape here. That's from using an automatic starting geometry envelope. So we're not giving it explicit bounds. We're just saying, hey, these parts need to be here. Do whatever you wish to get those two connected. The new design constraint added in Creo 8 or manufacturing constraint is the minimum crease radius design constraint. This will allow you to smoothen the optimized result and reduce the amount of web topology that's generated, by making sure that all surfaces keep curvature that are close to this minimum crease radius. And then finally, they added just some overall design regeneration stability. A lot of these, when you regenerate, or not a lot, but all of these, when you regenerate them or create geometry from them, will generate using freestyle surfaces. And so with some of these more complicated models, sometimes they're breaking in Creo 7. And so some overall design regeneration has been implemented in Creo 8. In terms of lattice functionality enhanced in Creo 8, there was some changes to stochastic lattices where they're now solid geometries and also have a trabecular shape option. But the big result is, or big change that we are going to talk about, is that lattice variability is now capable to be based on simulation results. So we could change our lattice density based on an exported numerical result. We can kind of see it here in figure 1 also. It'll be a little bit more clear in the demonstration, but we could see the density of the elements change throughout this little image here. We can also see stress results on these lattices because they are solid geometry. And so now I'm going to go into a little bit of a demonstration here to kind of highlight these tools. So let me open up our starting position. So right here, I have just a turbofan engine. And what we're going to focus on is the pylon that connects, the engine to the wing. So I don't have the wing, but I just have a pylon here. And all this pylon currently is if we just look over here in the model tree, is it's just, some simple geometries. There's nothing too complicated with it. But maybe we want to go in and lower this part mass. So let us go to this pylon start right here. So again, here it is. And to use generative topology optimization, we need to actually create a couple bodies here. So what I created is my initial body, which has all my features. That's body 1. And so if I only look at body 1, we see just all the geometry here is. And I also created a second body that is going to be preserved. So this is geometry that I need to be in my final design. The reason being is that, hey, this pylon is going to be connected to the engine, the turbofan. So none of this down here can change. And also it's going to be connected to a wing up top. So I just want to keep it, a constant. I think I put like a 10 something millimeters revolve to keep on the exterior here. So I specified that. Then what we're going to talk about is the generative design tool. So once we click on generative design, we could come into this tool. And this tool will follow a linear pattern up here. So we start on the left and work our way to the right to get our results. So the first thing we have is setting or starting geometry, which again is everywhere where that topology can be generated in. We have preserved geometry, so things that must be kept, and excluded, which is any areas that you would not want geometry to be created. After that, we could go and create an FEA simulation, structural simulation. So in this case, I just fixed the surface that's connected to the plane, the wing, saying it'd be bolted in. And I put a load pushing down where the engine's connected. Now, in the real world, there's more stuff going on with the pylon, engine, all that sorts of jazz. I'm just using this to kind of explain out the tools here a little bit. Next thing we have is design criteria. So if I edit the definition of my design criteria, here we can specify our design goal, which in the current build of GTO is to specifically limit our volume. So I said to reduce all of that starting volume geometry to 60%. And I also said, hey, I want a machinable solution here. Now we're going to be using these lattices, so I could have left this as 3D. And if we click add constraints, we could see the different types of manufacturing and geometric constraints we have. And so you could see that, there's a good amount of stuff we could change there. I just left it as this linear extrude to show this design constraint. We also have to specify a material. In this case, I'm using a titanium composite 6.4. And after that is constrained, we could change any of our study settings, which is essentially a mesh. The finer, more detail you have, the longer the GTO will take, but we'll get maybe a more refined result from it. And we can click optimize. It already ran this. You see it took about 6 minutes, so I didn't want to make us sit here for 6 minutes for it. And this is what the topology design came up with. You can see that although I set my limit to 60%, the best that GTO could find was 64.9%, given my manufacturing constraints. So to satisfy its regeneration and everything, it said 64.9% was the best it could do, which is what it gave me. We could show the simulation results, so we could specifically see where the stresses are on this part here. See, we get a lot of stress right up here. Makes sense because it's where the fixed region is. The next things we can do is we can actually generate the design. And so with the generate design, we could create a new part and we can actually have reconstructed, so full geometry. We could specify the level of resolution here. And we could generate it. So I already did that. So I'm going to close out of this, come to our next part, which is here. So we can see here, after we generate a design, we actually get a generative design feature in the model tree. And we could see that that geometry is placed here. Now, one thing you can do, and is actually what I did here, is you can kind of just use the GTO. So if I come to here and come back into it actually real quick, you can use this more as a rough guide and kind of make some changes that you want. So for example, over here, I didn't want to, I didn't really care for this random little hole to be here. maybe in the real world, us manufacturing this and drilling out this little hole might not really save as much time as we'd want, so we can get rid of it. And so in my actual machine, I just got rid of that hole essentially and did not use it for my reconstructed geometry. And you could do that just by playing with the freestyle shapes essentially that are regenerated. So it's all things you can modify. After that, next step I wanted to go into is using our lattice feature. The reason for that is if I come to my live simulation tab here, we see that my simulation is imported, from GTO still. If I simulate, what we're going to see is our stress is only at like 100, 10, 120, something like that. It levels out after a while, megapascals. And this is using Creo Simulation Live. And what I want to do now is I want to use these stress results inside of my lattice feature. So when I have this here set up, I can go to my query dropdown, and here's this export numerical results. And we can specify how many points we want. Now, there's no real limit to this, I believe, or it might be a very large number. I default to using like 1,000. I figure that that's a pretty good value to use. But obviously, the more you have here, the more accurately you can change your lattice density variability. So more points, the more accurately your lattices will be dispersed. So if you put in like 1,500 and press the check mark, that would go. This takes a couple minutes. I think it took me 3 minutes to generate the CSV. And what we actually get out of this, if I drag this over, again, it gives X, Y, and Z coordinates of the random sampled points. So in this case, I sampled 1,000. And then it gives the stress result at each of those points. And so that's what the CSV is. And this is available also in Creo Simulate. So just normal full Creo Simulate. You can export those numerical results to use here to get a more accurate dispersing, as Creo Simulation Live, isn't the most accurate simulation tool because it's not what's typically used for. That's a different discussion. So back to this, we also have the lattice feature to talk about. So I want to, give up some of my stress. I want to, increase the stress because we're nowhere near the tensile yield of my material, and I want to lighten up my material. Let's say, we have 3D manufacturing capabilities. So we're going to click on lattice. And in this case, I want to change all of that geometry that we made from GTO, which is this body down here. I want to replace it with a lattice, and I'll create a shell around it, let's say 10 millimeters. We could change some of the values up here. One thing we need to make sure we change is we want to change the simplified geometry. The reason for that is simplified lattice geometry needs to be used inside of simulations. So we need this to be simplified. We could go in and change our cell types here, so we can enter in cell size values. We could change the shape that we want to use. Cell fill, again, these are all things we could change based on what kind of latticing we want. And the important tab we care about is this density tab. And here's where we can actually change our lattice variability based on a simulation. Now, the first thing we need to do is input, our CSV. So down here at the bottom right, we'll change this to a CSV for simulation live data. Also, if you use a different FEA program, as long as you can export a density map tab that's delimited, you can also use those results. The other two options are Creo Simulate and Creo Simulate Live. So we can import a CSV. Then we could change the volume fractions to give some more user control of our lattices. Oops. And from that, we could actually, create our geometry. Now, again, this feature, creating all these really small lattices, if I zoom in here, right? Creating all of these is going to take about 4 to 6 minutes, I believe, is what it took me to generate this. So I'm going to cancel out and open my final. Just a second to cancel. Okay. And back here, as we can see, here's where I applied my lattice. If we zoom in, we can actually see, specific areas where the lattice is thickened versus maybe where they're a bit thinner. Like so, and we can come down here and see, much thicker right here versus to the right of it. And the cross sections also, are thickening, which we can see from our cross-sectional view. So that's our lattice feature. And again, this is simplified geometry. The reason being is that is more easily readable into a simulation software. So for example, we could come to simulation live and run the results. Now we could see, we increased our overall stress, but we lowered our mass. And I'm going to show us those values here in a couple of seconds when we go back to the PowerPoint. And so we can see, we actually see the stress results on our lattices. Those are things we can see. We show the max and mins. We see we have a maximum stress happening in one of these lattices beams down here. And this is all from Creo Simulation Live. So, these results are, they have errors associated with them, again, due to the nature of the tool. But when that's all said and done, we could apply this part, to our assembly here. And so although we have this, kind of crazy looking machine design on the outside, if we turn it on our cross section, we can see on the inside, we have all those lattices with a shelled, design here. That was that shell of our GTO result. And so now we combined our GTO results with our lattice feature, to create a design that's lighter and can still withstand the stresses that we applied onto it. And so if I come into my slideshow, we can see that we have, these 3 specific pylons that we're considering, right? We have the fully solid one, the just GTO, and the GTO with lattices. And if we compare the results, what we're really caring about here is this bottom table 2. Up on the top is the material I used. We could see that we drastically reduced the mass from iteration to iteration. And although we increase the stress, again, we're well below, our yield of this material. And so obviously, in the real world, these things are designed differently. But what this really does show is how we can use a combination of GTO and lattices to get a much more lightweight part that we can then, design and use. So that's everything for the demonstration and webinar. My name again is Anthony or AJ Vetterini, and my email's on the screen. I'm going to open the floor up to any questions you may have, which you can either place in the questions pane or in the chat. Well, I'll check both. If you want to see other webinars like this regarding a variety of topics, wind chill simulation, fixing up any models like step files, import data, doctor stuff, wide variety of topics. All those videos are on our YouTube channel. If you just YouTube boundary sys, will come up. You can also see our website here. And so yeah, I'll open it to any questions. If you think of any questions down the road, feel free to email me. Again, my email is right there. But that is everything I have for you today.